All right, so today's lecture is about the debugging tools that are built into R. So these come with R. They're not part of any package. And they can be useful for kind of figuring out what's wrong after you've discovered there's a problem, right? So how do you know that there's a problem? So there are a couple of indications that R will produce that that will give you the sense that there's something going on. And this is roughly the gradient. And so I think I mentioned this before, but basically there are three main types of indications. The first is a message, and a message is a very tame notification. It's just it could be a diagnostic message that something happened, but it could be nothing. Okay, and so the message won't stop your function from executing. It will just there'll be a message that gets printed to the screen, and the execution of the function will continue, and that's all. The next level up is the warning. Right? So a warning is another indication. Usually, if you're writing a function and you're trying to figure out, okay, what's a message and what's a warning. Furthermore, or if you're using a function and you're figuring out, well, what does that mean? A warning is an indication that something unexpected happened. It's not necessarily a problem, and many times you explicitly want to ignore warnings, but something unexpected happened. So the function was expecting one thing, and it got something slightly different. It wasn't enough to kill the whole thing, but it was enough to kind of trigger this warning. So execution of the function will continue if a warning occurs, but you'll get a message after the end. So you'll get a message when the function completes execution. So when the function comes back, when you get your console back, that's when the warning appears. So you won't get a warning in the middle of the execution by default. So these are generated by the warning function. Sorry, I should say the messages are generated by the message function. And then an error is the last stop, right? So an error is a fatal problem. This stops execution of the function, and error messages are produced by the stop function. And then there's a general notion of a condition, which is it's a higher level concept. All three of these things are conditions. And so you can imagine that, so you can create new conditions if you wanted to. So if you have, and generally you're not going to do this at this level, but if you have another type of condition that you want to kind of trigger when a special thing happens, so that's not an error, it's not a warning, and it's not a message, you can create your own conditions and using some of the functions that are available. So we won't be doing that now, but there is this notion of a condition, and it's generic. So this is your basic warning, right? You take the log of a negative number. You can't do that, right? Now, notice that you get a value back. It's a nan, right, not a number. But you also get this warning, which occurred after the execution of the function. And it just says that in the log of -1, nans were produced, right? So this is your typical, and sometimes that's fine. Because maybe you're taking the log of a bunch of numbers, and maybe some of them are negative, but you don't really care. And then you're going to make some sort of plot or something like that. So this is the kind of thing where you probably wouldn't want the function's behavior to just stop when any time it sees a negative number, because sometimes these things just happen. You get negative numbers on occasion, and you want to take the log anyway. So that's a warning. Now I've got a little function here that I've created. It's very simple. It takes your input. It checks to see if it's greater than 0. If it's greater than 0, it prints a message saying x is greater than 0. If it's less than or equal to 0, you get a message saying that it's less than or equal to 0. So very handy function I'm sure you'll all be using soon. And then last, I just want to mention this part here. So invisible is a function that that stops, or I should say, it prevents auto printing. Right. So normally if I'm at the command line and I type a function, remember, and I execute a function, the function will return the last element that's in its function body, right? So if the last element in its function body is a numeric vector, it will return that numeric vector. Now, what happens is that if you just execute the function, that numeric vector will be automatically printed to the console because it got returned by the function, and R will use auto printing to just print that to the console. If I call invisible on the return object, then it will still return the same object. But it won't do the auto printing. So you can call the function, and the object will be returned, but there won't be any auto printing. So an example of a function like this is the load function. So we haven't really used that much, but the load function loads objects from a saved workspace. So it's like the opposite of save, right? But when it loads the objects, it actually returns a character vector containing the names of all the objects that it loads. But that doesn't get printed to the screen because it's returned invisibly. Okay? So if you have a function that returns something invisibly, then what happens is that the object that gets returned by that function doesn't get printed to the console. And so sometimes you want that to happen, and sometimes you don't. Sometimes it doesn't matter. So here I just added this here just so I can tell you about it. It's not particularly important. But actually, I should say that any print function here, actually, all print functions will return the string that it prints. Okay, so when you say print x, what gets returned is a string x, right? But you don't actually see that because the return value is returned invisibly, right? So it actually so you could assign the output of print to like an object, but generally speaking, you never do that. So anyway, that was a little diversion on invisible. So here I create my print message function, and I call print message 1. Great, no problem. I get the message x is greater than 0. Okay. So and so what does print message return? Just before I go on, print message returns its argument, right? And so actually, if I had assigned the output of print message to some other object, it would be the number 1 in this case, right? Even though it didn't print out the number 1 anywhere. So now I'm going to pass it directly in NA, right? And I'm going to get an error here because you can't make the comparison if NA is greater than 0. It's not defined, right? And so it doesn't know what to do. It can't move on, and so it has to error out. Okay, so you get an error saying that in this expression, if x is greater than 0, the missing value, you have a missing value. So it was expecting true, false, and instead it got NA, which is neither true nor false. Right? Okay. So something happened there. That's wrong. Now I'm going to fix this problem, so to speak. I've got a new function, print message 2, and the first thing I'm going to do is I'm going to check to see if the argument's NA. Right? And so now if it's NA, I'm going to print this message, right? So it's not going to produce an error. It's just going to print a different message. So this function is going to print one of 3 messages for now, and then it's going to return its argument invisibly. So when I call this, so what's something that might typically happen? Well, I calculate the log of -1, and I assign it to x. So that doesn't stop anything. I just get a warning, and I move on, right? Now I'm going to print message on x, and I'm getting x as a missing value, right? So now there's no error there, but it may be unexpected, right? Because maybe I thought that, okay, well, the thing that I'm inputting into print message 2 is like some positive number, so I thought I was going to get the message x is greater than 0. But instead I'm getting this message x is a missing value. So what happened, right? And so this is the kind of thing where what you thought you were going to get, where your expectation is different from actually kind of what the function produced, right? And so all I'm trying to say here is, how do you know when something's gone wrong, right? So sometimes it's easy to tell, like in the case where we got the error message, but sometimes it's not easy to tell because here there's no error, but it's not exactly what I was expecting, okay?